What would this be? Negative ln of u plus c. Okay. Cool. Right, we use u sub. We could. Did you think I said z? Oh, you forgot the c. Well, that actually will come into play, but it won't mean anything in a couple of minutes. Okay. For the kids on the web, this is day 7. We're going to talk a little bit about power series and integration differentiation. What's the derivative of 1 d dx of 1 over 1 minus x? Who's got an answer? You got one? What do you got? Close. What's wrong with it? There's one thing. Yeah, there's no plus c on derivatives, right? What's missing? Negative out in front, right? Negative out in front. Oh, and then yeah, look at that. Then it cancels that, right? Ah, shoot, snap. You just did one of those dabbers or whatever that is. Oh, would it be true? Would this then be true? Yeah, and oh man, is that nice, right? Because isn't that just the sum from n equals 0 to infinity of x to the n twice, right? Times itself, right? Okay, so why is this useful? Well, don't look at that page. That's a mess. Let's look at finding the power series for natural log of 1 minus x. We just found that the integral of this thing equaled this. All right. Everybody okay with that now that we've done that last page? Okay, so what that does for us, you guys, is now we know this. We know about that. Well, that's equal to the sum from n equals 0 to infinity of x to the n. Now, believe it or not, you can integrate something like this with respect to x. Yes, you can. Okay, it's still just going to equal negative natural log of 1 minus x plus c. Okay, but all that I'm going to be integrating here is x to the n. Right? The summation can come out, and then I could just add up as I go from 0 to infinity. So all I'm going to integrate is this. And then this is just going to come along for the ride, and we utilize it later. All right, now, with this comes a little bit of abstract work, because what would be the integral of x to the 4th dx? X to the 5th over what? 5, right, plus c. Okay, so what would the integral of x to the n be? What did we do to 4? We added what? 1, and then we divided by that same number. So what we'd have is x to the n plus 1 divided by n plus 1. Ooh. Guys, we're close. We're very close. This is almost the power series representation of natural log of 1 minus x. Excuse me, negative natural log of 1 minus x. Okay, so I get this. Okay, so for a moment, what could we do to find c? What natural log do we know very well? Natural log of what? 1 is what? 0. So what if I made x equal 0? So let's say x equaled 0. Well, this would be the sum from n equals 0 to infinity of 0 to the n plus 1 over n plus 1. And that would equal negative natural log of 1 minus 0 plus c. Well, negative natural log of 1 is the same as natural log of 1, which is 0. And if I were to take all these terms and write them out, this would be 0 to the 1st over 1 plus 0 to the 2nd over 2 plus 0 to the 3rd over 3 plus 0 to the 4th over 4, which will be what? 0 as well, right? A bunch of zeros added up will be 0. So guess what? Oh, the constant of integration is 0. So it didn't really come out to mean anything to us. So what we can say is that the power series representation of negative natural log of 1 minus x would be equal to the series n equals 0 to infinity of, what did I have, x to the n plus 1 over n plus 1. It's amazing. We can estimate the natural log of any number based on that series. Further out we go with that series, the more accurate we'll be. Whew, sweet. So could I estimate the natural log of 2? Sure. Well, let's see. Negative natural log of 1 minus x. Let's first figure this out. What would x have to be for that to be true? Properties of logarithms. Properties of logarithms would tell me what can I do with the negative sign out in front. Say it's a negative 1. What can I do with that negative 1? Bring it as an exponent, right? So that'd be negative, or natural log of 1 minus x to the negative 1. Okay. And that would really just be natural log of 1 over 1 minus x equals natural log of 2. So naturally, no pun intended, naturally this would have to be true. If the base of the log is the same, that would have to be true. So I could solve for x. I don't like doing the whole cross multiplication thing. I'm going to do the reciprocal of both. So that would have to be true, which is basically cross multiplication, which means that x has to be 1/2. So I can plug in x equals 1/2 into this thing. Reminder, you're not being tested on this, but it's something to be aware of. I'm going to plug in 1/2 for x. And when I plug in 1/2 for x, it gives me a good estimate of what natural log of 2 is. What? Yeah. When I plug in x equals 1/2 and I go further and further out, the more terms I go out, the closer I'll get to the natural log of 2. Does that make some sense? A little bit along the way? You can watch this later while you're eating gummy worms and drinking Monster or whatever you do. So what if I did this? What if I did the sum of the first 10 terms of this? What would it look like? Ew. Well, it'd be 1/2 to what power? To the 1, right? 0 plus 1 would be 1 over 1 plus 1/2 to the what power? 2 over 2 plus 1/2 to the 3 over 3, and then we'd go all the way out to the 10th term, right? Okay, so if you, let's see, if you go out to the 10th term, I already did this calculation, so you don't have to use your calculator, but it would be about 0.69306. Will you type into your calculator natural log of 2? Let's see how close we are. Type into your calculator natural log of 2. I'll do the same up here. And let's see how close we are. Type in natural log 2. Dot, dot. All right, so I'm going to go to the old home screen. I hope I didn't screw this up. Whew. Okay, we're 0.08 off. That's pretty accurate. Okay, so your calculator, when it calculates the natural log of 2, it does this about as far out as you could in your entire lifetime, right? It gets that close. So it does this process. It uses power series in order to calculate certain. I want to do one more example. Oh, the arctangent of x. Oh, our friend, 1 over 1 plus x squared. You're so fun. Okay, so 1 over 1 plus x squared. Don't everybody jump out of your seat because of the excitement, okay? Do we all agree that this is something that we've established at this point? Don't forget the plus Charlie at the end, okay? Plus Charlie. Okay, so how could I write our friend 1 over 1 plus x squared as an infinite power series. Me, I'm good. Who's not good? David, are you good? Oh, okay. How could I write this thing in this form? How could I write 1 over 1 plus x squared in 1 over 1 minus something? Negative x squared. There we go. There we go. Okay, so what I could do here now is take this thing, this negative x squared, and of course take the negative out, write it as an alternator, and then x squared to the n power. Ooh, that's going to be a real nice power series. Ooh, yeah. Great. I feel so good about that. So much fun. Okay, now let's continue. I love power series. Power series are my favorite. You're not Santa. You smell like beef and cheese. Anybody? Anybody? Nobody? Yep. Okay, thank you. Thank you. The other day I said, we were talking about exponentials and honors pre-calculus. You're not an exponential. You smell like beef and cheese. And some kid's like, how'd you know I had that for lunch? It's like, oh, that was really awesome. Weird. Okay, yeah, that's ELF. That is straight up ELF. That's good stuff. I'm going to integrate this thing. It's not as bad as it looks, right?
That's always a good one.
Okay, so I'm going to integrate. Oh, I forgot the dx. Oops. I'm going to integrate x to the 2n dx, and I'm going to leave the summation portion of that on the outside with my alternator. Because the alternator is just a constant, you guys. It has no x involved. There's no variable involved. So how would I integrate that? Well, I'd add 1 to the numerator or to the exponent and divide by that same thing. So this would really be n equals 0 to infinity, alternator, and then this integral turns into x to the what power? What the integral of x to the 4th dx turn into? X to the 5th over 5. So I'm going to add 1 over 2n plus 1. That will equal what we've said over here, the arctan of x plus c. And I'm not going to go through the whole charade here, but the plus c ends up not mattering at all. It ends up equaling 0. C equals 0. So what we get here is, cool. There's a power series that represents arctangent of x. If I wanted arctangent of pi over 2, what would I plug in for x? Pi over 2. And then I could go out as far as I want, and I could calculate. What angle gives a tan? Well, pi over 2 wouldn't be a good one. No, we would take the arctangent of, like, say, square root of 2 over 2. That would make more sense. The arctangent of square root of 2 over 2 is 1, right? Because the sine and the cosine are the same. So if I took the arctan of root 2 over 2, and I plugged root 2 over 2 in right here, as I go to infinity, what would that equal? 1. Sick. Okay, that's probably enough for today. You're not testing on this.